Hello, everyone. My name is Alex Nusha Jafari, and I'm here with Irfan. Irfan, do you want to say hi?
Good evening. Hi, Alex. How's it going today?
It's going really well. I'm excited because we're going to learn chapter 2.3. The section is called Illustrating Information with UMLs. So, we're going to learn about UMLs. Once again, we are following from AB Computer Science Done Right. This is a book that is available on Amazon, and you can purchase it either an ebook or a hard copy. I'm the author of this book, and every video will be a section from this book or the homework problems of this section. All right, are you ready to get started?
Yes, I'm so excited. Let's start.
Excellent. Okay, Irfan, if you remember last class in chapter 2.1, or chapter 2.2, excuse me, we learned some really interesting things. Can you tell me a little bit about what we learned?
Sure, yes. So we learned how to tie classes together and how to describe different variants of information that belong to the same kind. We also got familiar with some keywords such as interface, implement, public, and dynamic dispatch.
Yes, that was very good, very quick as well. Yes, we learned about interface and implements and dynamic dispatch as well, indeed. I do want to talk a little bit more about interfaces just because I think there are some things that are a little bit more complex to figure out. So, if you remember, we created the exercise interface, and then we had strength exercise, I believe. And then what was the next one? We had,
Cardio exercise.
yes, exactly. We had a cardio exercise as well. And we had some things that were similar in both cases. And you may wonder, okay, why don't we put them in the exercise class? Or what exactly is this interface going to do? The way to think about it, to realize what should be in your interface and what should be in your specific classes, is that the interface is going to talk to the public. That's your like public figure, okay? So,
Okay.
an analogy that I like to think of is, let's say that you have a family business and you and your cousins and your uncles and your parents or whatnot are owning or running this shop, okay? And let's say that only one person gets to talk to the press. So when the press wants to talk to you, there's just one person that they come talk to. That one person is essentially the interface between um, your family's business and the press, okay?
Okay.
It doesn't matter how many things you and your family have in common. It doesn't matter that everything that, all of you have a particular share, or if you all have a name, or you all have whatever. What matters is, what does the press, what does the public need to know about your entire family or your entire corporation or whatever? That's what the interface needs to have. So every time you design an interface, you should say, what should the rest of my code base be worried about? What should the rest of my code base be um, have access to from um, the internal classes that I have? Does that make sense?
Yes, makes sense.
Okay. Um, if there's any more clarifications that's needed for interfaces, please let me know. And of course, our viewers should definitely feel free to make a comment if they have suggestions or questions, because then we can tailor the videos for those comments as well. All right, are you ready to get going?
Yes, let's go.
Excellent. Okay, so in this section, we're going to learn about UMLs. So let's say Yun, a friend of yours, has just joined your team and wants to learn about your design from previous section. How would you explain this design to her? How would you tell her, hey, this is what we've done, this is our code? Where would you go for?
I would just show her the entire code, I think.
I see. Okay. So, showing the entire code for something like we've built, how long would you say that would take?
It's gonna take some time, and of course, if she doesn't know about the coding process, she will get confused.
hmm Yeah, but I would say for something like our code that we've written together, maybe it will take 30 minutes, let's say, to give a very comprehensive, or maybe a little bit less. Um, However, what we're trying to aim for is people code things in a very, very complex systems. And those typically would take hours and hours. And it's very, very confusing for you and to keep staring at code. She might have a lot of questions for you. And you would say, oh, I'm not sure. Let me go back because it's probably code that you've written a long time ago. So it's very difficult to just show her the code because that's a lot of files in larger code bases. It's very difficult to verbalize things. So instead, what we do is you draw UML diagrams. Okay?
Okay, makes sense.
All right. So UMLs are called, let me use different colors because we're all about colors now. Uh, they are unified modeling languages. And the reason being is that, you could explain this in English, you could explain this in Farsi, you could explain it in any language. They're essentially just diagrams, so it's very easy to do so. So what you would have is simply a box to show a class, and at the top of the class, you would have the class name. So, for example, for you, it would be strength exercise, right?
Yes, so it doesn't have nothing to do with coding itself.
No,
It's just,
yeah. It's just the name of the class that you have in the code. Does that make sense?
yes, I see.
Okay. So that's the class name. Then we're going to go with the fields that the class has. However, we're going to go with the the name of the fields first. So for example, we have name, we have calories, and we have I think something like repeats or reps. Whoops. Repeats. And then followed by their type. So a name is a string. What was the calories?
It was an int.
Yes, precisely. And repeats would also be an int. All right. Now this is a UML diagram of strength exercise. Does that make sense?
Yes, makes sense.
Perfect. Just a second. All right. Excellent. So we can do the same thing for our other classes. So what was the other class that we should write, uh, I guess, a UML diagram for?
It was an cardio exercise.
Yes, exactly. So similar thing here. I start with the name. So I'll go with cardio exercise. And I draw a line right below it to show that I'm going to the next section. All right. What were some of the fields for cardio exercise?
Again, it was a name,
Mm-hmm.
calories, and the duration, I think.
Name, calories. I think for cardio we had distance, right? Because with
Yes.
a cardio you would have something that you're going for. So a name is a string. As you said previously, calories were also in cardio, or yeah, in cardio exercise. What about distance?
It's also an int, I think.
Yes, exactly. Excellent. Um, Afterwards, we draw yet another line below the fields, and we go ahead and write all the methods that is available. So I think we had something like get name, which was, of course, type of string. We had get calories, which was also an int. And then I guess we had get distance. Does that make sense?
Yes, it does.
Perfect. Similar thing for the strength exercise. We can have all our getters in this UML diagram. Does that make sense?
Okay, yes, it does.
Excellent. All right. So now, if I show you these two diagrams, you should be able to see precisely what the code would be like. Look how small this is. Look how tiny this thing is. But it's super quick for you to read, and you get all the important informations in there. Does that make sorry. Uh, yeah, so you have all the important information in there. Are there any questions about this, or do you feel like it's fairly simple to understand?
I think it's easy to understand.
Excellent. Okay, perfect. Now, one thing we learned about is the interface. So, how do you think we go about um, representing the interface as a UML?
So they need to be connected together, these two classes, by
Right.
the interface.
Okay, yes, for sure.
But I don't have any idea of how are we going to represent this.
So, interface is just like classes, if you can see. So, classes have their name, their fields, and their methods. Just like a class, an interface would start with their name. So, our interface was called iInterface, right?
Yes, I exercise,
I
I
exercise,
suppose.
sorry, yes. I exercise, exactly. And then we draw a line underneath it. What did the exercise have?
It had a name, it had calories.
Yes, exactly. So it had a name and calories. Oops. All right. And in order to essentially connect these, all you have to do, actually, let's move these guys around. Let's move this down. Oh no. Okay, let's not move them around. Not
Okay.
laughing. Let's move the strength exercise down a bit more, right here. And let's move the cardio exercise down too. Oh no. Definitely we'll have to edit this part out. Jesus. Okay. Try number 5. Let's move this down some more. Okay. بذار خندم تمام شه بشه دیلیت کرد.
ببین تو که قراره این پارت رو به هر حال کات کنی.
آره
من
میدونم.
پشیمون شدم از اینکه اونجا ازت نپرسیدم اگه نبود اینترفیس باید چی کار میکردی. واقعا منو ببخشید که اون موقع نپرسیدم.
اشکال نداره الان اینجا میتونی بپرسی. بذار بنویسم بعد بذار بکشم بعد بگم که خب الان متوجه میشیم که این strength exercise و هستش این کاردیو exercise و به انترفیس
آها
ربط داره.
آها
سوالی
آره
هستش
اوکی.
بعد تو میگی آره یا نه. خب آماده ای؟
بریمش.
All right, so yeah, let me just clean this up a little bit. Okay, and we can just essentially draw a box around the cardio exercise. So we now have a strength exercise and a cardio exercise. And essentially, cardio exercise and strength exercise both implement eye exercise. So just like this, the little arrows will, I guess, arrows like this indicate that this interface is implemented by these two classes.
Okay, so we represent the interface with the arrows, right?
Yeah, so this, we already know it's an interface because, typically we have it start with an I, but that's just a convention that I use. But we know that it's being implemented by these because of the arrows, because of this arrow.
Right. Yes, and one more thing just to clarify.
Yeah.
How would we do the coding part if we didn't want to use the interface?
So you're saying if we didn't have an eye exercise, what would happen?
Exactly.
Okay. Well, okay. So let's think through this actually. Let's think through this right here. So let's imagine. I'm gonna do red for imaginary things. Let's imagine that the person class needed an exercise. And essentially, what I needed to do is, let's say I needed to calculate. Remember how we did the calculation of calories per, how many calories does an exercise burn per person's total calorie count?
Yes.
Essentially, get calorie percent, I would believe. So if we didn't have the eye exercise, we had to have two methods. We had to have one method that takes in a cardio exercise and returns a number for calorie percent point. And then we had to have another method that takes in a strength exercise. Even though both of these methods would essentially look very, very similar, but because we are taking in two different types of exercises, you can't just tell Java, I promised you it takes something, and I promise that it will give you this answer. You have to be explicit. We have to have a signature, right? Remember, we have to have an input and an output.
Right.
So if you don't have this eye exercise, then your input needs to be, well, sometimes strength exercise, sometimes cardio exercise, and you can have, hundreds of different exercise types, and you would have to have hundreds of different methods for the exact same calculation.
Okay, now I understand. It makes our work much easier.
Exactly. So now the person class, because it doesn't care about what kind of exercise it is, it can just say, hey, the input is going to be an exercise and the output is going to be a number. That's all it cares about.
Now I see. Yes, it makes sense now.
Excellent. I'm so glad. All right, so that's essentially UML classes. They're fairly easy and they're not too difficult, but they're super helpful because now through this diagram, you can go through your designs. You can first sketch out your design and see, oh, yes, this makes sense. This should implement this. This should implement this. Oh, no, this doesn't make sense because if I need this, then I can't have this. All that great stuff. Okay, are you ready for your favorite part?
I'm absolutely excited. Let's
Excellent.
go.
We are gonna go for our homework in gray because we are feeling pretty gray when we have homeworks. Alrighty. So the problem we have is if you recall from a previous section, section 2.2, we traveled back in 1800s and we had different kinds of bread. Do you remember this?
Yes, I do.
Okay, so I have some shocking news for you. When you traveled back, someone destroyed your computer because they thought you were a witch, and you now no longer have your program or code in your computer anymore. So you have to draw a UML diagram of your code because now all you have is quill and paper. So I'd like you to draw a UML diagram of your solution to the previous section's homework. Does that make sense?
Yes, it does. Let's do it.
Excellent. Great. Well, have a wonderful time drawing things, and I'll see you next class.
See you. Bye.
Bye.